standard 4. So in this standard, we were given two sectors of a circle with 12 centimeter radius, and we were to find the volume of each sector as a cone. And so I wrote the volume of a cone equation right there. Volume equals 1/3 pi radius squared times height. And so back to the sectors. We were given two sectors, one with 180 degrees central angle and a 120 degree central angle. And so for each sector, I found the arc length first, which would just be 2 pi radius times whatever angle over 360. And so the radius obviously is 12, as you can see here in both examples. And then regarding the angles, this is 180 over 360, 120 over 360, and thus yielded 12 pi for the 180 degree sector and 8 pi for the 120 degree sector. And so then we know the arc length, which would also then be the circumference of the circular base of the cone. So with that knowledge in mind, we can now find the radius of the cone. So we know that circumference equals 2 pi r. We can plug the circumference value in for c. So 12 pi equals 2 pi r and 8 pi equals 2 pi r. Then solve that out to get r equals 6 and r equals 4. And then the last thing we need is the height. This can be found out with a variation of Pythagorean's theorem. So this example would use 12, which is the slant height, which I wrote as L, as the hypotenuse of the triangle, and then the radius and the height would be the bases. And so I wrote the equation down as L squared minus R squared equals H squared, and then we know that L is 12 and the radius R found out in that portion. And so it's 12 squared minus 6 squared equals H squared for the 180 degree sector, which was then later found out as with a height of 6 squared of 3. And similarly with the 120 degree sector, it's 12 squared minus 4 squared equals H squared. So that cone has a height of 8 squared of 2. And so we plug back in those variables, r, radius, height, into the equation. And so for the 180 degree sector, we have volume equals 1/3 pi 6 squared times 6 squared of 3 equals 391.781. And then for the 120 degree sector, we have V equals 1/3 pi 4 squared times 8 squared of 2 equals 189.563. Alright, and then for B, I practically just applied the same method with a 240 degree sector, which would just be 2 pi for the arc length. That's 2 pi times 12 times 240 over 360, which is 16 pi. And then you can find the radius. 16 pi equals 2 pi r, r equals 8. 12 squared minus 8 squared equals h squared, h equals 4 squared of 5. And plug r and h into the equation again. So it's 1/3 pi 8 squared times 4 squared of 5, which yields 599.451. Alright, and then for C, to make a volume equation using, given the angle of a sector, I just referenced back all the work and backtracked. And so using the original volume equals 1/3 pi radius squared times height, I found radius to be the arc length, and then you'd use the circumference formula to find radius, which is the arc length is 2 pi 12 times x over x get, which is the angle, over 360 over 2 pi. And so the 2 pi's cancel out, so then you're just left with 12 times x over 360. And for height, it's practically just square root L squared minus R squared. Substitute L and R in, so it'll be, so height is square root of 12 squared minus 12 times x over 360 squared. And so your final equation for volume is V equals 1/3 pi times 12 times x over 360 squared times square root of 12 squared minus 12 times x over 360 squared. And so for D, the domain of this equation is xe 0, 360, because we're only limited to the input is only limited to the angle of the given sector, and that can't be below 0 or above 360 because the circle has a max angle of 360. And so using E, I graphed this whole equation into my calculator and found the maximum to be 294 degrees, yielding a cone with a volume of 696.499. And so this is the whole sector. And so when I was drawing out the cone, I just found out, like, oh, it's just 12 times 294 over 360, which is equal to 9.8. And for the height, it's square root of 12 squared minus 9.8 squared, which is around 6.9. And so that's the radius, that's the height, and that's the slant height.